Hi guys, welcome to your 2.2 notes on solving two-step equations. By the end of the day, you will be able to solve equations with 2 steps in one variable. Before we begin, I would like to talk to you about birthdays because mine is coming up and this is very important knowledge for you guys to know. So when you wrap a present, the first thing you're going to do is you're going to close the box and then you're going to wrap the paper around the box and then you'll tie the bow or put the ribbon on or things like that, right? Now, to unwrap a present, you have these steps. You first are going to untie the bow or take off the ribbon, and then you unwrap the paper, take the paper off, and then finally you open the box. Now, what do you notice about the order of these steps? Well, let's look. If closing the box is the first thing you do, to undo that, it's actually going to be the last step. To unclose the box is the last step in unwrapping the present. And then if you wrap the paper second, that's still the second step in opening your present. And then finally, in wrapping it, the last thing you do is to tie the bow. But the first thing you do is you untie the bow. So while, yes, you are undoing the steps, you're untying, you're unwrapping, you're unclosing, you're opening, right? While you're undoing things, the order is reversed. So while you go 1, 2, 3, you actually go 3, 2, 1. So to undo any process, to undo anything with multiple steps, you are going to undo the steps, but you're going to undo them in reverse order. You're going to undo the order, reverse. That is our key idea of the day, you guys. So to solve two-step equations, we will end up using the properties of equality and the inverse operations we learned about yesterday or our last lesson to form a series of equivalent equations, of simpler equivalent equations. We're going to make our life simpler and simpler and simpler, but we're going to use order of operations backwards in the reverse order. So you'll remember from yesterday that the goal of solving any equation, our end game, our final goal, is to isolate the variable. I'm sorry, I can't decide what color I want to use. We want to isolate the variable. We want to get the variable all by itself. We want to end up with just the variable by itself on one side of the equals sign. So to do that, we're going to undo what's happening to our variable. But when you zoom in on example 1, number A, yes, I said number intentionally, you'll notice that yes, we have our little x right here on. We want to get him all by itself. However, there are 2 things happening to our variable. There's a +3 and there's a ×2. So how do we know what to do first? Well, we have a throwback day. Remember PEMDAS, the order of operations, which tells you to do parentheses, exponents, multiplication and division, and addition and subtraction. We're going to take that and we're going to undo it in reverse order. So the first thing that we want to do is we want to add or subtract to get the variable by itself. And then we want to multiply and divide to get the variable all by itself. Finally, we're going to undo any exponents and undo any parentheses. So in this first one, the first thing we want to do is undo the +3. So to undo that, we're going to -3 from both sides. And that gives us 2x equals 15 minus 3 is 12. Now that 2x equals 12, we're going to undo the 2 times. So we're going to divide by 2 on both sides, giving us x equals 6. And we got it. Awesome. Cool. Cool. Now let's check our work. If we plug in x equals 6 into our original equation, is it still true? Is it true that 2 times 6 plus 3 equals 15? And again, since we're checking, we'll put a little question mark over our equal sign. Well, now we're going to do PEMDAS to check it. So we don't have parentheses, we don't have exponents, but we multiply. 2 times 6 is 12. Plus 3 equals 15, maybe. And then our last step is add or subtract. 12 plus 3 is 15. Oh, hey, look, that's 15. Super, we did it right. Cool, cool. Now, predict. What should the first step, this is kind of a tricky equation actually. What should the first thing we do here be? Now I said it's tricky because like we've got this t over 2. Helpful hint, if you want to rewrite this t over 2 guy as 1/2 times t, you may. If you want to leave it as t divided by 2, that's fine. I'm going to leave it as t divided by 2. So again, we want to undo what's happening to our variable, and we're going to do that in this order. Just going to sneak this guy in here right there. Okay, first, add or subtract. So we're going to add 3 to undo the minus 3. And we get 5 plus 3 is 8 equals t divided by 2. Now we want to undo this divided by 2 guy. So to undo that, we'll multiply times 2 times 2. Okay. The divided by 2 and the times 2, those will cancel out, giving us just t on our right side. And on our left side, 2 times 8 is 16. Notice that we are using our properties of equality. We are we're adding 3 to both sides. We're multiplying by 2 on both sides. So that's where properties of equality come in. You need to do the steps on both sides. Okay, now let's check our work. Did we do it right? Well, we found out that 16 equals t, so we're going to plug in. We're going to substitute t equals 16. That will give us 5. Does it equal? We don't know. 16 over 2 minus 3. Again, we substituted 16 for our t. So we're going to multiply and divide first. 16 divided by 2 is 8. Is 5 equal to 8 minus 3? Well, 8 minus 3 is 5, so yay! We did it right. Okay, cool. Now that's pretty straightforward if you have the problem given to you, but sometimes you don't. In fact, most of the time you do math, you actually do it in a real-life real-life situation. There's a word there, and I'm going to remember as soon as these notes are done. Anyway, so when you're doing life in a real-life context, there it is, context. There we go. Context is the word we wanted. You need to figure out what you need to figure out. So here we go. Let's figure this out. So here we go. You've got a bulletin board that you're going to make to advertise community service opportunities in your town. You plan to use half a sheet of construction paper for each ad, and you need 5 sheets of construction paper for a title banner. If you have 18 sheets of construction paper, how many ads can you make? Well, that's a lot of information. Let's break down what we know. Okay, what do we know? We know how much paper it takes to make an ad. It said, hey, you need half a sheet of construction paper to make an ad. So we know you need half a sheet of paper for each ad. You also know that you need to make a banner. It says you need 5 sheets of construction paper to make your banner. So for your banner, that's 5 sheets. And finally, we know that we have 18 sheets of paper in total. Great. Now, what is the question? What is this asking? It says, how many ads can you make? So we need to find the number of ads we can make. I need to find the number of ads I can make. Okay, cool. And just so we're clear, the paper per ad, that's guy right here. So, what's our plan? Well, let's make an equation. When we solve our equation, we will know how many ads we need. So because that's the question, that's going to inform what our variable is. you want to make your variable what you need to find, because that's going to be the answer to your problem. Okay, so the variable will represent what we don't know, which is the question that we have. Okay, so let's put this into a model. We know that we have to zoom out to see all the information we need. I'm going to work backwards. I know that I have 18 sheets total. So here are my 18 total sheets. I also know that whatever this is, 5 of these sheets need to be for my banner. So I'm going to say, hey, here's my 5 sheets. There's my banner. Now with the rest of the space that we have, half the number of the sheets are going to be taken up, or rather, however many I have left, these are going to be made into half sheets. So I would end up, we're going to end up multiplying by 2 to find out what that number is. Okay, so half sheet for ads, which means I phrase this kind of awkward, I'm sorry. Half of the number of ads will be whatever is left in this space. Okay. So let's write our equation. We know our total is 18. So we're going to say 18 is equal to 1/2 times the number of ads. So that's our variable. Let's say A equals number of ads plus 5. So here we go. That's our equation. Now, let's solve it. We want to get this A all by itself. So to do that, we're going to undo what's happening to our A. Minus 5 on both sides, giving us 13. So 13 equals 1/2 A. And then we multiply by 2 to get A all by itself. And we're left with 26. I almost said 16. We're left with 26. So 26 is the number of ads that we can make. So final answer, I kind of ran out of room. We'll say 26 ads over here. So breaking that down backwards, if we have 18 sheets of paper, we take out 5 of them, we're left with 13 sheets. And if each ad takes half of that, we double 13, giving us 26. We have 26 ads. Cool? Cool. Now we have 2 more examples to make sure you get it. So it's one thing to know the steps, but what's more important is knowing why you do what you do. So for each of these examples, we're going to do the steps we talked about earlier, but we're going to explain exactly what is happening, what our reasoning is. That's what justify each step means. Justify means explain why you do it. Okay. So here we go. Looking at this guy, I remember that my end game is to get x all by itself. So I want to undo what's happening to my x. And the first step is this divide by 3. Because when you have this in a fraction, it's like there's little parentheses up here. I almost hiccuped, but then I didn't. So we don't have adding and subtracting outside of this. We have multiplication and division, exponents, and then we'll do what's in the parentheses. Okay, so first we're going to multiply by 3 on both sides. And we're going to call that the multiplication property of equality. Oh my goodness, you guys, these words are so long. Let's abbreviate from now on. Okay, so we have the multiplication property of equality, which cancels these guys out. Awesome. So bye, giving us x minus 7 equals negative 12 times 3 is 36. Okay, sweet. So that step, we can even say that that was simplifying. Yeah. Sorry, I'm going to no, you know what? I'll rewrite the problem for you on the next one. I'm going to leave this one alone because time. So now we want to undo what's happening to our x. So we add 7 to both sides. And that is the addition, abbreviating, addition property of equality. So negative 7 plus 7 is 0, so we get x. And then 36. Oh, shoot, you guys, I forgot the negative. Okay, negative 36. Negative 36 plus 7 is negative 29. So here we call that simplifying. There you have it. X equals negative 29. Now it is very important to go back and check your work to see if we did it right. Now that we know that x equals negative 29, is it true that negative 29 minus 7 over 3, well, that's negative 36 over 3 is negative 12. Yeah, nice, we did it, cool. Okay, pause the video. Try to solve this guy all by yourself. Remember to say why you're doing what you're doing. Okay, here we go. So if we have negative t plus 8 equals 3, what we want to do is we want to get this t all by himself. So we're going to undo what's happening to our t. My first idea is I want to subtract 8 from both sides. I subtract 8 from both sides because the subtraction property of equality says that if I subtract the same number from both sides of the equal sign, they're still equal. Oh, sorry, that's the subtraction property of equality. There you go. And to clean ourselves up, we cancel these two out, giving us negative t. And then 3 minus 8 is negative 5. There we just simplified a little bit. And we are almost there, getting t by itself. We need to divide by negative 1. Oh, I'm sorry, I didn't rewrite it. There we go. Okay. So dividing both sides by negative 1, we are allowed to do that because that is the division property of equality. Now, you do not have to divide by negative 1. You could multiply by negative 1 because of the multiplication property of equality. Okay, anyway, so now we're going to simplify our lives a little bit. This negative cancels out over here, giving us 5, and this negative cancels out over here, giving us just t. T time is at 5. Awesome, let's plug it into our original equation so we know that it works. Is it true that negative 5 plus 8 equals 3? Yes, yes it is true. We nailed it. Okay, so whatever is happening to your variable, just undo it. And you gotta undo PEMDAS, undo in backwards order. It'll be great fun. I hope you have a fantastic time on your homework.